All right, hi guys. This video is made to go over the majority of the topics from Unit 1 for your final. I would not say that this has everything. I strongly suggest you going and looking at the review guide on page 247 and 259 or through 259 to get some more practice and other skills as well, and going back into your notes. But I do think that this has the majority of the stuff that you're going to see on your final. So I just want to go through this, and then you can go ahead and look at that 247 to 259 to get some more practice. So Unit 1 was really heavy in vocabulary. So we're just going to go over what the vocabulary looked like and then how we can use it in statistics. So the first couple questions decide whether something is qualitative or quantitative. Remember, this qualitative is like a quality of something. So words, color, like what color something is, and then quantitative is our number values or a quantity that describe things. So qualitative is more of like quality. Quantitative is a number or value. So if we look here, the average wait time in the cafeteria, wait time would mean that you're looking at a number. How long did you wait? So this would be quantitative. And then colors of off-road vehicles sold in the United States. Again, you're looking at the color of something. So that's a quality of the car. So we would call that qualitative. All right, so then our next things we were talking about is if something is continuous or discrete. Discrete is our countable numbers. So we typically think of this as like 1, 2, 3, 4. The only exception to that would be money. So whole numbers and money. Continuous is decimals, things that we can't quite count because there's so many decimals that we're talking about. So if we look at our examples, and at any time feel free to pause, try them, and then see what the answers are after. Don't feel like you have to just copy down what I write. At any point you could pause, try these 3, and then see if you got them right. So number 3 is bus fare. I guess so that's money, so that's going to be something that we can count. So that would be discrete. Those would be discrete data. Number of exits off the highway from Denver to Colorado Springs. If you think about exits, you can count how many of those there are. Even if you think about just driving, you could count. Those are countable. That's countable data. So that will be discrete. And then the weight of a FedEx package. If you think about this, this could be like something weighs 1.5, 1.51, 1.510, 1.512. The decimals, the amount of decimals and places that we can go to make this so, there's so many values that we wouldn't consider this to be discrete. We'd consider this to be continuous. All right. So then our next section is our nominal, ordinal, interval, and ratio. Nominal is names of things. So it's our nominal and ordinal are qualitative things. The only difference is for ordinal, the order matters. So nominal could be like colors, I don't know, other things that have quality of something. Ordinal, though, would be that the order that you're given matters. So if we're talking about like ranking in the military or grade that you got in the class, right? A, B, C, D. The order that of what you get is in some sort of order that takes place. Interval and ratio are quantitative. Remember, for interval, your really options are if we're talking about temperature or years. They don't have a natural, the 0 does not mean 0. So like 0 degrees outside does not mean that there is no temperature. 0 years does not mean that there is no years. So those are kind of the 2 examples we rely on for interval. Ratio is any other numerical value that we may get. So again, feel free to pause and try these. But number 6, prices for a motorcycle engine. So this is going to give you a quantitative, right? It's a number, so it's either going to be interval or ratio. So because it's not temperatures or years, this is going to be ratio, right? 0 means it costs $0. That's a natural 0. Marital status of patients in a physician's office. So marital status, married, single, divorced, all those things. That would be qualitative data. And then because there's no order to it, the order does not matter. It would be nominal. Final grades in a class. So this would be like getting an A, B, C, or D. Yeah, this is considered qualitative data. We're not talking about like the percentage that you get, just the grade, the letter grade. But the order here matters, right? Getting an A is better than getting a B. So this would be ordinal. And then years of elections. Yeah, we're talking about years here. So this would be a quantitative amount. And then because it's years, this is going to be interval. All right. So then our next section, if something is a parameter or a statistic, parameter means that it's talking about or it has data on the entire population. Everyone is included in this data. Statistics means that you just picked a sample. So there's a small group of people out of the total. So smaller group is statistic, population is off of the parameters based off of the entire population. So number 10 says a recent survey of company indicated that the average income of 250 out of 900 employees was this amount. So because they only asked 250 out of the 900, this is a sample of the entire population, which means this statement is a statistic. The average salary of all assembly line employees at a certain car manufacturer is $33,000. So we asked all of them. So because all of them were concluded in this data, in this value, then that means that this is a parameter. And then the average late fee for 360 credit card holders was found to be $56.75. There are definitely more than 360 credit card holders in the world. So then this is just a sample of the entire population, which means this numerical value is a statistic. All right, so if we look at the bottom section, determine which of the following is an observation, a variable, a sample, statistic, or a population parameter. So a 2010 General Social Survey asked the question, after an average work day, how many hours do you have to relax or pursue activities that you enjoy? To a random sample of 1,155 Americans, the average relaxing time was found to be 1.65 hours. So, right, this amount here was only a sample. So we know that this value here is our sample statistic. This is the value that we got after from our small sample. Here it's asking the average number of hours all Americans spend relaxing. So since this is trying to find it for everybody, this would be our population parameter. So then the number of hours spent relaxing after an average day of work, that's what we're trying to gather. That would be the observation that we make, the amount of time they spend. So this is our observation, which means our variable, right, what we're looking for, the numbers that we're collecting has to do with the Americans in the sample, how many people we're involving in this sample. Okay, so then moving on to page 2. A couple more things on vocab. Yeah, if we're looking at which types of studies are observational or experimental. Observational means that you're not doing anything, you're just observing. There's no involvement of you. You're basically asking a question and collecting data. Experiment, there's usually like a control group. You're trying something out with these people. So a study of the salaries of college professors in a particular state. Yeah, you're just collecting data. You're not manipulating anybody. You don't have a control group. You're not doing something to someone and not to somebody else. So this is just observational. You're just collecting data. A study where a political pollster wishes to determine if his candidate is leading in the polls. Again, you're just going around and asking people who they're voting for. You're not changing anything. You're not experimenting on these people. So you're just collecting an observation. So it's observational. You're just asking a question, gathering responses. A study of a new medicine and its effect on blood pressure compares the results with a placebo group. So you're giving these people this medicine, and you're giving some people, right? Placebo means that they're not getting the medicine. So you're giving some people a medicine and some people not, and then you're comparing the results. You're giving them medicine, which means you're experimenting on them. So this is experimental. All right. So then our next one is random, cluster, stratified, convenience, or systematic, which type of sampling that we're using. So random is just as it sounds. You're just picking a random sample. Clustered and stratified are pretty similar. Remember, these both break people up into categories. So we would break people up into categories. A cluster is going to pick one whole group or maybe two whole groups. Sorry. So a cluster is going to pick two whole groups to study. Stratified is going to pick like 2 or 3 people from every group. So a cluster takes the whole group. Stratified takes just a couple people from every group. Convenience is just what it sounds like. We ask people where conveniently. And then systematic is where we ask like every 4th, 5th. There's a system to your process. You ask every 3rd person in line, or you call every 4th number in the phone book or something like that. So again, if you want to pause it and try to figure out if you can identify these on your own, that would be a great idea. If not, go ahead and we'll just go over the answers now. So every 10th house we choose to include in our income survey. So 10th house, yeah, you're asking every 10th house means that we're asking systematic, right? It's a system of how we're asking people. Out of all the science classes at Grandview High School, 8 are randomly selected, and all students in these classes are interviewed. So, right, we're putting people into groups by what science class they're in, but then we're selecting all the students out of 8 groups. So this is going to be a cluster, right? We broke it up into all of the science classes at Grandview, and then we just chose to select everybody that's within those classes. Names are put into a hat and 5 are drawn. That would be random. Our population is women in the U.S., and in each state we randomly select 3,000 women to be included in our study. So you are putting them into groups by state. We're making groups by state, and then we're selecting 3,000 women from each group. So within each of these, we're picking 3,000 women. So this would be our stratified. We grouped them by state and then picked an amount from each of those. To avoid working with late, the quality control manager inspected the last 10 items produced that day. That would be convenience. All of the teachers from 85 randomly selected nation's middle schools were interviewed. So we asked all of the teachers from 85 random schools. So again, we grouped them by what middle school they teach at. And then we asked all the teachers at those particular schools. So that would be a cluster. All right, so then the last part of this unit was probability. So let's go over some probability questions. What is the probability of rolling a 5 twice in a row on a 6-sided number cube? So trying to roll a 5, if you think about a number cube, your chances of rolling 1 5 would be 1 out of 6, right? There are 6 numbers. Your chances of getting a 5 is 1 out of 6. If I'm trying to roll it twice, that means I have two separate situations. I wanted to roll a 5 the first time, so my chances were 1 out of 6. Then I want to roll a 5 again, so my chances are 1 out of 6. And I would multiply those two together. So multiplying straight across, 1 times 1 is 1. 6 times 6 is 36. All right, a bag containing 6 green marbles, 6 orange marbles, 6 blue marbles, and 13 pink marbles. What is the probability of drawing a pink marble followed by a green marble without replacing the first one? So first we want to know the chances of drawing a pink marble. So if you think we have to figure out how many marbles there are total, and then what's the odds of drawing a pink one. So there are 31 marbles total. If I add 6, 6, 6, and 13 together, that gives me 31. And my chances of getting a pink one would be 13 out of 31. And then I want to get a green marble. Now the big thing, it says without replacing. So assuming that I drew out a pink marble, there are now only 30 marbles left in that container, right? I did not put it back. So there are 30 marbles left. And now the odds that I get a green marble would be 6 out of 30. So now you're welcome to multiply straight across and then reduce. I see here that I can reduce this fraction and make my life a lot easier, right? 6 and 30 are both divisible by 6. So I'm going to change this fraction to 1/5 instead. So then I'm multiplying 13 over 31 times 1 over 5, and then that might just reduce how much. It'll make it easier later to see if there's anything I need to divide out. So I get 13 over 155, and since 13 is a prime number, there's not really going to be anything I can divide out of that. All right, a bag containing 6, or kind of the same problem, same situation. What is the probability of drawing 2 blue marbles with replacing the first one? So if we think about the first one, our odds, right, there's 31 marbles. Our chances of getting a blue one is 6. Now we put it back, so there's still 31 marbles here, and our chances of getting a blue one, right, we put that first blue one back, is still 6. I don't see anything that I can reduce here. So if I multiply straight across, I get 36 times 900, or over 961, and that does not reduce, so that would be our fraction. And so then our last example, what is the probability that the first card is an 8 and the second card is a jack without replacement? So we're not going to put it back. So the probability that the first card is an 8, so remember there's 52 cards in a deck. So my chances of getting an 8, there are 4 8s within the deck, so it's going to be 4 out of 52. And then I did not put that card back, so there's only 51 cards left, right? Imagining that we drew an 8 in the first one. We now have an 8 off to the side, and I have 51 cards left in my pile, and now I'm trying to get a jack. Well, there are 4 jacks left in the pile. So we talked a lot about simplifying. 4 out of 52 simplifies to 1 out of 13. So I would suggest simplifying that first. Instead of having to try to divide out later. So then I can't simplify 4 out of 51. So then when I multiply straight across, I get 4 out of 663. So my answer would be 4 out of 633. All right, so that's my review on Unit 1. Again, I would get some more practice going back to that 247 in your workbook for some more Unit 1 review, but hopefully this kind of was a good refresher on what we did.